Welcome back, Earthlings. This is going to be part one of a three-part series on substitution. Now, we've seen substitution before, but this is going to be sort of the culmination of my favorite example of it in tricky problems. All right, so in part three, I'm going to make this point again, but part three is really going to tie into some things we've seen previously. It's going to incorporate a lot of stuff. All right, so this one's going to deal with substitution and scary equations, typically polynomial equations, stuff that looks like this that I have on the left, but it doesn't have to be polynomials. All right, so I want to make a slight distinction because we've seen substitution already. For example, in the Art of Math series, in the series video number 54, where we had systems of equations, and you take, let's say, the second equation and rearrange it so that you have x is 8 plus y, and then you substitute that back into the first one. So I want to make a slight distinction. That's what I term using substitutions, because it's sort of handed to you. You have this equation, and now you're going to use it in another place. So today's a little bit more creative. It's about creating a substitution. So if we take a look at this equation, we want to solve this. Now this is a fourth degree equation, so we just know quadratic equations. We don't really know how to solve third degree, fourth degree, and higher. So this looks really scary, hence the title of the video. So what we need to do is create a substitution. Now, what gives us this idea? If we look at this, this kind of looks like a quadratic equation, except this is a 4 and that's a 2. So if somehow this said x squared plus 4x plus 3, we'd be fine, except it doesn't say that. So we are going to create a substitution. You could call it any letter you want. Let's call it y. So you could call it a, b, c, whatever. So y is going to be x squared. So if we think of this as in terms of y's, then what is x to the fourth? Well, that's now y squared, because if you square x squared, you get x to the fourth. Plus 4, now we want to get rid of all the x's, so x squared is just y. So here's the idea. We took this scary equation and now transformed it into something that looks pretty doable. So this is a quadratic equation, and if you look at it closely, you could tell that it can be factored this way. All right, so we have our solutions. Y is -1 or -3, but we're not done because we have to go back to the original. So x squared would have to be either -1 or -3. So in this case, we're going to get imaginary solutions. So this x would be plus or minus the square root of -1, or plus or minus the square root of -3. So disregard the fact that they're imaginary, but the technique still holds. So we created the substitution. That's the key idea. So we're going to do the same thing for number 2. I'm not going to do it all the way through because I think you guys will get the idea. So what substitution should we do here? And by the way, it need not be into quadratic equations, but the same idea sort of you can tell by looking at this. What's sort of the building block? It's this x cubed. So let's treat our y as x cubed. So now this is going to be 2y squared minus 5y plus 8. Now you can use the quadratic equation on this or try to factor it, do whatever you want. But once you're here, you're going to get solutions for y, blah, blah, blah. And then how do you find the x? You just take the cube root of whatever you get here. So that's the idea there. Now, number 3. We could try this trick again, so maybe we say, hey, let's call y is equal to x squared again, and this time we're going to get y squared plus, I'll skip this term for a second, that's going to be 4y plus 1, and this x cubed is actually the annoying part because it's not quite a y squared, but it's not a y, so it would be y times the square root of y. So that's kind of going to give us an extra x. And if you look at this, we haven't really gained much. This looks really ugly. So why did I give us this third example? To show that substitution doesn't solve all of your problems. So we're going to fail on this number 3 because this is not a quadratic. We have 1, 2, 3, 4 terms instead of just 3. So we can't do anything with this. We'd have to square the whole thing to undo that square root. But then once we square it, we're back to a fourth degree equation. And that's hard as well. So it doesn't solve all our problems, but it's a pretty powerful technique. Next, So it doesn't have to be with one variable. You can do more complicated things. So let's take problem number 4, where you have x to the 4th, y to the 4th, minus 2x squared, y squared, plus 1 equals 0. So here the question is, clearly there's not enough information to solve this, but I'm restricting it such that I only want the integer solution. So x can't be like 1.3. It has to be a whole number. It can be negative, positive, integers. All right. So what's the building block? So to see how to use substitutions, what appears over and over? So here we saw that the x squared can get us both of these terms. So that's just going to be like our y, that's our y squared, that's our y, that's our y squared. Here we saw it didn't really work, but here if you look at it, you could think of xy, or maybe x squared, y squared as a building block. So if we call y x squared, y squared, we'll have y squared minus 2y plus 1 equals 0. And then this factors, so y minus 1 squared, well, or y minus 1 times, just so you guys can see a little bit better. That's how this factors. And so you get a double root, the same answer twice, y is equal to 1. So that means x squared times y squared has to be 1. Oh, sorry, terrible thing on my, so our substitution, I reuse the same letter. So let's call this maybe A. So then this is going to be an A. That's an A. All of these are A's. All right, so A has to be 1, and that has to be equal. So basically x squared, y squared has to equal 1 with integers. So the only way to get that is if x is plus or minus 1, or if y is plus or minus 1. So if you mess around with these combinations, hopefully you'll see that all of these solutions work. Now I want to make one extra point. Maybe you didn't think to create this substitution. So maybe you just said, let's call A just xy. So then you'll have a to the 4th minus 2a squared plus 1. And then you could do a substitution on top of a substitution. So say, hey, now I'm going to call b a squared. So now this becomes b squared minus 2b plus 1 equals 0. And then you get the same thing. So the point is, if you don't see the mega substitution right away, that's fine. You could do 2 intermediate size substitutions. But it should come out, if you see the full substitution, I would just go straight to the original one of x squared, y squared. All right, I'll leave it there. And here's a practice problem for you guys. I'm not going to do this one, but I encourage you to try it on your own. It shouldn't be too different for number 4. So it's 5a over b equals negative a squared over b squared minus 6. Now, so try to leave a comment with an explanation and your solution, and I'll give feedback. I'm just going to give you guys, so you could pause it here if you want to think about it. I'll give you guys one hint if this seems a little harder than what we've seen. First thing you might want to do is rearrange it so it looks like all the stuff on one side. Notice we have zeros or whatever, a number, but all the terms are on one side. Here I have terms on both sides. So maybe put all the terms on one side first, and that'll help you see what to do. All right, so comment, let me know what you guys think about this. See you guys in the next part.